C4 2017, question 4, the volume of a solid created by revolution question. To be fair, bit of a stinker. I know, let's put in a sec x function. That would have thrown a lot of people. Let me show you how you work through this one. So, as normal, we know we need to square the y equals function. The volume is the integral of pi y squared. Don't forget to check these two things in brackets because it's a squared plus b squared plus 2ab, which a lot of candidates forget. So, that'll be cos squared x. That'll be 2 of the product of them, and that will be sec squared x. And we need to find the integral of that, bring pi outside. And the limits they tell us are pi over 3 and pi over 6. Make sure your calculator is in radians for this question. Right. Integrating cos squared x, we're going to swap it for a double angle. Half plus half cos 2x, no problem there. This was the tricky bit you had to spot. Don't forget, sec x is just 1 over cos. So effectively, that's 2 cos x over cos x. The causes cancel, and that just leaves a cheeky 2, which a lot of people didn't spot. And the last one is even harder to spot. The integral of sec squared, you may not have done that in class. Actually, it's a simple one. It goes to tan x, and that is in the formula booklet, which we don't often look at. So, this effectively is what you have to integrate to half plus a half cos 2x plus 2 plus sec squared x, all with respect to x. Okay, moving it up a bit. That integrates to a half x. Don't forget when you're integrating this, the 2 will come out as a half. Half times a half is a quarter, and cos integrates to sine. So that's a quarter sine 2x. 2 will integrate up to 2x. And as I said from the booklet, the integral of sec squared x is just tan x. Then all you had to do was press some buttons, put pi over 3 in for x into all of them. You get 4.56 recurring. Put pi over 6 in for x into all of them, and you get just over 2.1. Subtract them, multiply by pi, and it was 7.74 cubic units, and that was 7 marks. Quite tricky, that one. Question 3b on the 2017 C4 paper. It's the R alpha method. It's pretty bog standard, asking for a least value later on. So with 6 marks this year, we will take that. So let's have a look at it. We've got root 5 cos 5 plus root 11 sine. Obviously square, add root the coefficients to get R. That's a nice and easy one. Root 5 plus root 11 all squared is 16. Square root of that is 4. Because it's the cos one, alpha is tan to the minus 1 of b over a. So tan to the minus 1 of root 11 over root 5 equals 56. So then we can substitute our root 5 cos plus root 11 sine. For this year, 1 over 4 cos 5 minus 56 plus 6. It asks for the least value. To get the least value of that fraction, we need the maximum denominator. The maximum any cos value can be is 1. And that would happen at cos of 0. So we would need the angle to be 56. As 56 take away 56 is 0. That's the first part. And what would that least value be? Well, if the maximum of this is 1, 4 ones are 4, plus 6 is 10. So the least value is 1 over 10. For 6 marks, you've got to be happy with that. Right, question 3 on the 2017 C4 paper. Looks an absolute stinker. Show that that equation equals that. And then hence, solve that. It's actually not that tricky at all. There's your little clue. We got a sine 2 theta. This is a double angle question. We got cos squared and sine squared, and we got to turn them all into tan. So we're just looking to use a couple of identities and set up a little quadratic and factorize it. So this is how you do it. Here's the equation they're giving you. You need to spot that is the double angle there, sine 2 theta. So let's swap it for this one. Sine 2 theta equals 2 sine theta cos theta. And it then looks like that. Don't forget you've got to multiply the 7 by the 2. Now, we know we've got to turn it all into tan. So I thought let's divide by cos squared theta. This one will disappear. This one will become tan squared. Sine squared over cos squared is tan squared. This one here, that cos will cancel with one of these causes to leave a sine over cos, which is tan. So it works out quite nicely, and it just comes all the way down to 5 plus 14 tan theta equals 3 tan squared theta. Rearrange it to get in the quadratic form. 3 tan squared minus 14 tan theta minus 5 equals 0. It'd be pretty harsh of them to give us one that doesn't factorize. This one does. It goes into 3 tan theta plus 1 and tan theta minus 5 equals 0. So obviously tan theta equals minus a third for that bracket, or tan theta equals 5 for that bracket. Plug those numbers into your calculator. The question only asked for it from 0 to 180, so we haven't got to worry about adding on too many 180 degrees. There's your answers to 2 DPs, and that was worth 6 marks. So even though it looked horrific, it actually wasn't that bad at all. Happy days.